A new feature request comes in, and the natural instinct for any developer is to dive right in. You pull up your editor, start typing out logic, and immediately begin building the requested functionality in isolation. And then you hit a wall. You realize you can't save a user profile because the database schema hasn't been finalized. Work completely halts. At this point, developers usually make a couple of critical errors. They either sit silently and wait for the blocker to clear, or worse, they treat an assumption as a solved problem and write code for a database structure that doesn't actually exist yet. A single unmapped requirement hiding deep in the architecture can stall an entire release cycle. You spend hours writing code only to realize the surrounding infrastructure isn't ready to support it. This is where dependency mapping becomes essential. A dependency is quite literally anything your work needs to move forward, to execute correctly, or to be safely deployed. Mapping these out involves hitting 4 specific targets. You have to identify what is going to block you, the exact sequence things need to be built in, the points where different systems integrate, and the communication required between teammates to make it happen. By charting these elements ahead of time, you remove the guesswork. A chaotic, reactive development sprint becomes a highly predictable sequence with significantly lower risk. Dependencies span several different domains of a project, and the most common roadblocks actually start with the human element, requirements, and people. Take a look at this requirements section. It poses a crucial question. Can we proceed with an assumption? If you're building a dashboard but the metrics aren't finalized by the client, moving forward on an assumption is incredibly risky. Moving down to the people dependency category, we see how progress freezes while waiting on specific individuals. Your code might be perfect, but if it requires founder approval, peer review, or a careful developer handoff, you are stuck until they are ready. Once the human decisions are locked in, you run into the technical core. This is where your code relies entirely on previous setups being completed. Looking at the technical dependencies, constraints are clear. You cannot start front-end UI until the back-end API returns data. Panning down to integration dependencies, Reliance stretches to outside systems. An app hub, for example, depends entirely on an external authentication service. The tightest, most elegant code you write is useless if the required systemic data isn't flowing, or if the initial human decisions were never actually finalized. So, the code is written, integrations work locally, and you are ready to deploy. This is where hidden dependencies do the most damage. Notice the deployment dependency section right here. The successful launch is completely tethered to environmental variables and specific Docker setups. Discovering you're missing a domain configuration or a crucial Coolify deployment script right at the finish line means your release fails in front of everyone. Neglecting to map out how the code lives in the real world turns a strategic software launch into a chaotic gamble. Because dependencies are inevitable, development teams have to triage them based on severity. A blocking dependency means exactly what it sounds like. Work cannot continue in any meaningful way until the issue is entirely resolved. Under blocking dependencies, you cannot implement application permissions without defined user roles. There is no code to write. Right below, non-blocking dependencies allow partial work. For instance, the front-end team can build interfaces using a mock API while the back-end is constructed. Categorizing these hurdles ensures your team maintains their momentum. You isolate the hard stops and you keep moving wherever a workaround is viable. To actually build this map, you follow a straightforward sequence. You list out the exact work being planned, identify the specific inputs you need, and group those dependencies logically by category. If we look at this dependency table for a task manager, we can see the operational steps in action. Every hurdle is assigned a specific owner, a current status, a blocking level, and a defined next action. Having this structured format is incredibly valuable for human teams, but it becomes an absolute necessity when you start using AI coding agents. Look at this example prompt block. By feeding the map directly into the AI, you explicitly instruct it to use a mock user for local development and avoid implementing final permission inheritance. This prevents the AI from hallucinating a fake authentication system. The dependency map acts as a shared set of rules, forcing both human developers and AI tools to operate within the exact same boundaries. Ultimately, Mapping dependencies ensures that you answer 4 critical questions before anyone writes a single line of code. As the summary points out, you need to know what is needed, who owns it, does it block progress, and what is its current status. Answering those questions systematically exposes the hidden risks in your sprint. It gives you an engineered path to keep your team moving, clear the roadblocks before you hit them, and reliably ship your product.